Alright, 5.8, solving problems with exponents and logarithms. So the first thing we're going to talk about is the word annuity. So what annuity is when you are continuing to make payments on something and it's calculating interest, either because you're gaining money because it's an investment, or because it is taking money off of your debt, which is, they're both good things. So, the first question says, determine how many monthly investments of $200 would have to be made into an account that pays 6% annual interest compounded monthly for the future value to be $100,000. $100,000! Sorry, I like to be RuPaul sometimes. Okay, so let's put all of our variables out. A, P, I, not R. N, T. And let's do 1 plus, no, let's not do that. So our A value is $100,000. Okay, P is going to be $200. We're making $200 investments. Our interest rate is 6%, so 0.06. It's compounded monthly, so N is 12. And we are looking for term. So when you are doing an investment, this is the formula that you are looking for. So because we're looking for t and t is in there, what I'm going to do is I'm going to isolate t before I put any of the brackets or the numbers in. Because that sounds easier to me. So I'm going to divide by p first. So I have a over p equals 1 plus I over n to the power of nt minus 1 over I over n. Now I'm going to times both sides by I over n. So I have a over p times I over n. And that's going to be equal to 1 plus I over n to the power of nt minus 1. Now I'm going to add 1. So I have a over p I over n plus 1 equals 1 plus I over n to the power of nt. Now I need to take the logarithm of both sides. So many steps. So I have the logarithm of all of that, a over p times I over n plus 1, and this will have nt log 1 plus I over n, and then I'm going to divide by n log 1 plus I over n on both sides. So what we're actually using for the formula is log of a divided by p times I over n plus 1 over n log 1 plus I over n. And I'm just going to go from there, not p, equals t. I'm going to plug all my variables in now. So it's a little bit more work. I think it's a little bit less work to do all your manipulating first and then put the numbers in so you don't screw anything up. And you can't round. You're dealing with money. You shouldn't be rounding. This is a grade 12 math class. You should be better than that. We don't round. Okay, so we have log of 100,000 divided by 200 times 0.06 divided by 12. And then you're going to add 1 divided by n, so 12 log 1 plus 0.06 divided by 12. And you can simplify if you want to, but you should also be able to just type this into your calculator. But you should have log, if you type all of that in, you should actually get 3.5. It simplifies to be 3.5, so that works out really nice. Over 12 log of 1.005 equals t. And you should get 20.93 something, 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 something. And that answer that you're getting is years. It's going to take you 20.93 years. So without clearing your calculator screen, so type log of 3.5 divided by 12 log 1.005. Take that answer and times it by monthly payments, because it's asking how many months. And the number that you should get is 251.178 months. So that's how many months it would take to get your investment to be worth $100,000. Or you could lip sync for your life. Two ways, I don't know. One seems more fiscally responsible than the other. Okay, a person borrows $15,000 to buy a car. The person can afford $300 a month. The loan will be repaid with equal monthly payments of 6% annual interest with compounded monthly. How many monthly payments? So same thing we just did. It's not R, it's I. But we're going to go 15,300, interest rate of 0.06. N is going to be 12, and we are looking for t. So we're going to use the other formula this time, because it is a loan. So same thing as last time. I'm going to manipulate the formula first. So I'm going to divide by p. So I have a over p equals 1 minus 1 plus I over n to the power of nt over I over n. I'm going to times both sides by I over n. So I have a over p times I over n equals 1 minus 1 plus I over n to the nt. I'm going to subtract 1, so I have a over p I over n minus 1 equals negative 1 plus I over n to the nt. I do not want this negative, so I'm going to change it to a positive and change all the other signs. So it's negative a over p times I over n plus 1. Now I can take the log of both sides. So I have log of negative a divided by p times I over n plus 1 equals nt log 1 plus I over n. And I'm going to divide by n log 1 plus I over n. So this is the formula that I'm going to be plugging it into right here. So let's do that over here. So we have log of negative 15,000 divided by 300 times 0.06 divided by 12 plus 1 divided by 12 log 1 plus 0.06 divided by 12. So you can simplify this. Inside the brackets, you should get sorry, I was just trying to follow along with my notes. You should get 0.75 divided by 12 log of 1.005, and you should get from this 4.806 dot 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 dot, and that's years. To figure out your monthly payments, take that number without clearing your calculator screen and times it by 12, and we get 57.68 payments. It's also asking how let's also figure out how much they pay on the loan. So if I take this same number without clearing my calculator screen and times it by 300, the number you should get is $17,304.04, and you should be able to get it down to the exact same cent as me. That is how much you paid total on the loan. The loan was only supposed to be $15,000, so in the end you ended up paying $2,304.04 in interest. Okay, last one has to do with intensity of an earthquake. It uses this equation, m equals log I over S. So the most intense earthquake ever was in Chile in 1960 with a magnitude of 9.5. Haiti experienced an earthquake with a magnitude of 7. Calculate the intensity of the earthquake in Chile and Haiti, and how many times as intense is Haiti over Chile. So Haiti, let's do Haiti first. So we have m equals log of I over S. And it tells us that the magnitude in Haiti was 7. So we have 7 equals log I over S. And now what we're going to do is we're going to change this into an exponent. So remember, this exponent rate, or this base right here, is 10. So we know that 10 to the power of 7 is I over S. And we're going to times both sides by S. So 10 to the power of 7 times S equals I. And S is just a standard earthquake. It's like a unit, like S earthquakes. So the intensity is 10 to the power of 7 S. So 10 to the power of 7 times the standard earthquake. Okay, let's do Chile. Same thing, but their magnitude was 9.5. So 9.5 equals log of I over S. We're going to change that into an exponent. So 10 to the power of 9.5 equals I over S. Multiply both sides by S. So we have 10 to the power of 9.5 S is the intensity of Chile. So if we wanted to figure out how many times as intense Chile was to Haiti, we're going to make a proportion of Chile to Haiti. So we have 10 to the power of 9.5 S over 10 to the power of 7 S. S's cancel, so we have 10 to the power of 9.5 over 10 to the power of 7. If we divide, we're dividing, which means we can subtract our exponents. So 9.5 subtract 7 is 2.5. If I type in 10 to the power of 2.5, we get 316.227. So Chile was 316.227 times as intense as Haiti. Alright, and that's the end of logarithms. If you can't love yourself, how are you going to love logarithms? Okay, bye!